So here's an example that is similar to problem 37 on section 810. The directions say find the first four non-zero terms of the Maclaurin series for the function by multiplying or dividing the appropriate power series. So let's show you if they gave you f of x equals sine of x over 1 plus x. I personally would rewrite this as sine of x times the quantity 1 over, and you could multiply by 1 over 1 plus x, but to save myself a step, I'm going to write that as 1 minus negative x. And let's talk about why I did that. Remember the sum formula for an infinite geometric series. This definitely has that shape of a constant term over a constant, either adding or subtracting a variable term. And so in this case, I would be able to see that this 1 here on top would be my first term. And then since I'm subtracting negative x here, then that means that negative x is my common ratio. And if I can notice those things, then it would give me a clever way to get the Maclaurin series that would result in this sum. And I hope you have sine of x memorized. So let's show what we'd have. I'm going to move over here so I have a little more room. So f of x would then equal, for sine of x, we would replace it with its Maclaurin series. Remember, sine's an odd function. You've got all odd powers, all odd factorials. Oops. And the signs alternate, starting off on a positive term, and then alternating. Okay, so that's the power series. I've just substituted it in for sine of x. Now for the power series that would result in 1 over 1 minus negative x, your first term being 1. And then I'm just going to keep multiplying by negative x, my common ratio, to generate the rest of the series. There we go. Okay. All right, now the fun part, multiplying an infinite polynomial by another one using the distribution process. It's not going to be as bad as it sounds, because it sure sounds bad, doesn't it? But they really just want the first four non-zero terms, and we are definitely going to take advantage of the fact that that's all we're held accountable for here. So, so let's get started. So this would equal, okay, so you're just going to see me using the distributive process, and I'm just going to distribute x in, and I'm going to, distribute it into the first four terms, and then take advantage of a plus dot 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 after that. Okay, or maybe I'll do a little more than 4 just to kind of show you that this isn't as bad as you would think. So what would I get when I multiply x in? I would get x minus x squared plus x cubed minus x to the 4th plus x to the 5th, and so on. And I like I said, I think I'll go ahead and just show a couple more, especially since the pattern is super simple. Okay, so that's what I got when I distributed the x in, and now on the second row, I'm going to show the terms that I would get when I distribute the next term, negative x cubed over 3 factorial, into all the terms on the other side. And when I write this down, I'm going to line it up by its like terms, because we will have to add everything together. Again, it's not as bad as it sounds. So negative x cubed over 3 factorial, multiplying that in, I'm going to line up the first term. When I multiply it by 1, I get negative x cubed over 3 factorial. Then I'm going to distribute it into the negative x here, so I would have positive x to the 4th still over 3 factorial. Okay, you multiply it by the x squared. Okay. Now the truth is I've already kind of worked harder than I have to, because I'm just going to be held responsible for the first 4 terms. And if you don't see it yet, you'll see it soon. There will be nothing to add to x, so that will be my first non-zero term. There will also be nothing to add to x squared, so that will be my second non-zero term. What I get here will be my third and then my fourth. So I'm kind of done, but just to let you kind of see how I know that I'm almost done. Oh, and do I have a mistake? Yes, I do. Okay, that should be a minus. There we go. Okay. Okay. So let's go ahead and show multiplying the x to the fifth over 5 factorial in. So distribute that in. And again, I'm going to line it up with its, oops. Okay, x to the fifth over 5 factorial. Oh yeah, times 1 is x to the fifth over 5 factorial. And then x to the fifth over 5 factorial times negative x. And then, you know, and so on. And then you could always distribute x to the seventh in, but I hope you can see if I did, my lowest powered term would be to the seventh. And so there's kind of no need. So I'm just going to say like, and, you know, I don't know. And you just keep going, I guess. I'll just put 3 dots like that. Like you kind of keep going. But because of all of that infinite multiplying business, I was only responsible for the first 4 non-zero terms. You could see, I'm hoping pretty clearly that you would end up with x and then negative x squared. Combine your cubic terms here, 3 factorial 6, so we'd have 5, 6x cubes. And then combine your 4th degree terms here, we'd end up with, you know, something like that. And then we just get to be super happy that we weren't held responsible for the rest of it. And there you go. I'll bring down that little f of x, and then this would be your answer for something like this. All right, my friends, I hope that helps. Have a great day.